Okay, now let's solve this together. It gives us two really complex requirements, and you can see that the first one is simpler. So let's try and actually analyze this. First thing you'll notice is that there is a BC here and a BC here. So you really want to factor that out. Well, you might consider moving this to the right hand side. BC squared minus BC times CP. Bingo, that's just BC times BP. So AB squared is equal to BC times BP. And hopefully you immediately realize that this is equivalent to this angle being equal to this angle. It's just a similar triangle. Let me just write it. Triangle ACB is going to be similar to triangle PAB. Now, another way to interpret this is that this angle will be 180 degrees minus angle BAC, which is just 180 degrees minus 112 degrees, 68 degrees. So we know this angle. We want a way to find this green angle over here. So we just need to find this purple angle. Well, this purple angle, kind of looks like a right angle, but we haven't proven that yet. Let me just not label that angle. Anyways, I drew this diagram by trial and error, but then it actually looks like a right angle. So it's kind of, reasonable to suggest that this might be a right angle. So now let's analyze the second condition. What does the second condition imply? Well, if we actually want this to be a right angle, we actually need to find angle C. How do we find angle C? Well, we could actually apply the law of cosines, but okay. So now let's, without loss of generality, assume AC equals 1 and AB equals 2. This will simplify things up. Now we can try and find BC. B is just square root 5 minus 4 cosine 112, so it's plus 4 cosine 68 degrees. So this is BC. Well, that means we will know what cosine C is, but it'll likely be really messy. But still, we can try and find it at least. CQ will be equal to cosine C, which is equal to BC squared 5 plus 4 cosine 60 degrees. AC squared is 1 and AB squared is 4, so minus 3. And then you have 2 times this whole chunk on the bottom. That's a little too big. I mean, a little way too big. Let me see how I can. Okay. Now, this is. Okay, I know we can simplify it a bit. This just simplifies to 2. And then dividing by this 2, we get. It's just 1 plus 2 cosine 68. I'll just write it as C over square root plus 4C. Okay, now that looks much better. So remember that C is actually a constant here. So we know CQ. We can just plug into this equation. Well, we know BC is right here, which means that 3AC squared is just going to be, okay, hold on while I make one thing clear. This equation is based on AQ perpendicular to B. It might be wrong, but if AQ is actually perpendicular to BC, then this should be correct, and we can check it by plugging in. BC's actually cancels out perfectly with CQ. You can see it's 5 plus 4 cosine 68 degrees here, and 5 plus 4 cosine 68 degrees here. Well, after it cancels out, it just, well, 1 plus 2c. Wait a second, we have our 2 here. Don't forget to multiply by 2. So it's 2 plus 4c actually, which is 5 plus 4. It sounds familiar? It's right here, which means b square is actually bc square is actually just this, which means our hypothesis that this is a right angle is actually true. Actually, how you really work through this is that you first solve what CQ should be, and then you realize that this, you somehow realize that this is just the cosine C. I'm not sure how you're supposed to find this, but, well, you can work backwards. So, now that we know this is a right angle, the rest should be really straightforward. So angle PAQ is just going to be 80 degrees minus 68 degrees. And now we have our final answer of 22 degrees. And we are